Hi, welcome to another edition of C Programming. My name is Nate Nestler, and this is Hyperactive Studios. Okay, so let's go over here and let's create a new project. So I'm just going to say File right here. I'm going to say New Project. All right, and I'm going to choose C, and I want to create a new C application. And it's telling me C, C++ application. And you can choose what one you want. And this works right here. Let's say Next on that, and I have it set to C here. And let's call this for looping. So that way we know that this is going to be for loops with C here. Okay, and I accidentally put a colon there, which I didn't mean to type. Alright, make sure this is set to C here, and it's going to go ahead and create our main file for us. I'm going to say finish here, and it's going to pop up. And I'm going to need to right click this and say set as main project. Now, if you're having trouble with getting it set, you could also come up here to, I believe it is run, and you can say set main project there, and you can say what project it is you want to set from here. In this case, I'm going to select for looping. So there's how to set your project up. Okay, now back in our project here though, for our for looping, we need to go into our source files, right? And we need to double click on main. So that way we get this to come up, and then we can code this next one here. So I'm just going to do a real quick example. And a for loop is a counting loop. Now technically we could do this with a while loop. It's just more difficult. So it doesn't make sense to do that. So I'm going to create a variable. I like to call variables that count, because I think it's logical and makes sense. Then I can just say for here, open close parentheses. I'm going to space that out a little bit. I'm going to say count equals 0 for starting value. And then I'm going to say count is less than maybe 10, for instance, semicolon. Then I'm going to say count plus equals 1, like that. And if I do open close curly brace like this on it, I'm going to say printf here, open close parentheses, semicolon. I'm going to say double quotes, and I'm going to say enter the the count is, let's say %d, because this is a integer, like that, and then comma, and then let's say count on this. Okay, cool. Just like that. Let's go ahead and remove that there. One other thing I'm going to do is put /n in here. I'm going to put a period also while I'm at it. And let's say Control S to save it. And that's my simple little program. That's it. So there's to that. Very, very simple. But if I run this, boom, we get the count is 0, count is 1, count is 2, count is 3, count is 4, count is 5, count is 6, count is 7, count is 8, and count is 9. So very cool. So let's have a look at how this works. So let me drop a breakpoint in here, and let's look at what's happening in the memory of the program and how this is all being executed and what's happening here. So if I run this in debug mode, it automatically pops here to this point. And of course we have nothing for our output, but over here in our values here, our count right now is some crazy massive negative number. But once it gets initialized, that all changes. So let me just step over that variable. You'll notice now count is 0. And then I'm going to step over the next one here. And what this is doing is saying that count is going to start at 0 for this first number set here. And then count is going to go up to 10, meaning it's going to be less than 10. The moment it hits 10, it's going to stop doing this loop. And count's going to increment by 1 every time. So count is 0. This is the same thing as saying count equals count plus 1. So essentially, if I were to write that, this would be count equals count plus 1. The way this works is it takes the value of count here, which right now is 0, and you would say 0 plus 1, and that's 1, and then that 1 then gets assigned back in the count, and then count would then be 1 because of the equal sign right here where it gets assigned back into it. So that's basically how that works. That is equivalent to same thing as count plus equals 1, if you will. That's the same thing, right? Okay. So those two things are the same thing. So when we say count plus equals 1, it's just a shorter way of writing this, so that way you don't have to write it all the way out. Count equals count plus 1, because we do it so often and so much, we can just get away with saying plus equals like this. Okay, then open curly brace here, and then printf here is just going to display our message. We're going to say %d for an integer here, and then period to /n here. Close quotes, comma, count is going to be the current count of each iteration in a loop, and I'll show you that. So every time we loop through, we get to see the value that's stored inside of count. And this has a lot of benefits, particularly with arrays, but if I come in here and say step over, you can see count is 0. And it goes back up to our next loop iteration. And our next loop iteration, count is now 1, right? Because it's getting incremented. So check this out. And then now it's going to display it. So I'm going to say step over it. And now you see count is 1. And that's going to do the next loop iteration here. And count is going to get incremented by another 1. And I'll prove that again. Say step over. Check it out, count is now 2. Then when I step over again, it's going to display it. So now count is 2 is displayed. And it's going to keep counting all the way up here for memory. See how it's going through those different loop iterations like that and displaying them? Now here's the problem we're going to have. This is going to be 10 now. And so when we hit 10, it's going to exit out this loop, because count has to be less than 10 for the loop to continue. So the moment we hit 10, which it just got incremented 10, I'll prove that to you. Notice that count is now 10 when we execute that loop that incrementer there for our loop. Once we did that, it had to exit out the loop because count was no longer fitting within the range of the requirements of this loop. It had to be between 0. Well, it couldn't be, basically not between 0. It starts at 0, but it couldn't be larger than 10. 10 was the maximum. So the moment it hits 10, it drops out of this loop, and we're done with the display and get to the exit, the end of the program here. And that's basically how a for loop works. And you could use this with a lot of different things, like arrays and things of that nature, which we'll get to a little bit later here, where it lets you step through each loop iteration bit by bit, and then you can basically step through the different values inside of a loop. So this is pretty cool. There's one other type of loop we could talk about here, and that would be the whole basically do while loop. So let me just turn this off here, and let's say here while open close parentheses is what we're used to seeing, but we're going to put a semicolon at the end. And the reason why is because up here we're going to need to say do, and then we're going to have open curly brace and closing curly brace. And this is a do while loop. It means it has to do the first iteration of the loop execution one time. And then we're going to end on some condition. And this can be useful if you want the loop to always execute at least one time. Maybe wait, see. Let's see here. Printf, I guess. Printf, open close parentheses, semicolon. How about in quotes? Do you want to continue. And we can set up the standard good old y/n for yes or no, colon, space, like that. And then I'm just going to say scanf, those parentheses here, and parentheses on this. I'm just going to do a %, I think it's C. Might have to do an LC, I'm not sure on this. And then I'd have to have some kind of variable here. So I would need some kind of variable. I need to do a char. And let's call it response, I guess, equals no character. So I'm going to put in single quotes like this for a single character like this for a char. It's going to have response like so. And I'm going to put an ampersand in front of response because this is going to the memory address for it. And we'll see if I remember correctly or not for a single character here. I think it's C, but it could be wrong. I guess we find out, right? And then we can use our good old if statements to then test something here. And that is this response, equal to yes with a capital Y, or is response equal to lowercase y, because they could have either one inputted, right? Whether or not they put shift or not is a whole other ball game here. And then I'm just going to do open close curly braces here. Technically I don't have to, but I'm going to. And then I'm going to say, let's just set up a boolean 2 here. And let's create a bool. Let's call it not finished. Equal to false. They may not have this, and yeah, I don't think they do. All right, so let's just do 0 for false and 1 for true, and let's make this an integer. Int. Okay. I might have to set a condition on that a little tighter than that. We'll have to see. But default in the computer is 0 is false and 1 is true, technically in the computer, and so you can actually get away with this. So not finished. You know what? I want to make this a little easier to read, so I'm going to go ahead and do it that way. And not finished is equal to true. And of course, it's throwing a fit at me because it's changed the name of the variable there, but I didn't change it up here. And then this one's going to throw a fit because I haven't changed it down there yet. Okay, there we go. Now it's going to be happy at me. I'm too lazy to type that again, so I'm just going to come over here and select it like so. Actually, I'm just going to select that whole thing because it saves myself a lot of time. Say elif in sum, but in this case it's going to be else if for C. N, but this is going to need to be a capital N. Like that, and then this is going to be a 0 instead. And then else, they didn't type the right thing, right? It's just going to make them loop anyways, so. It's also going to be not finished, whatever else they did too. Now technically, with a 1, because I mistyped it, we're going to have to loop again, because we didn't get the response correctly from them. So this way, it'll post a question to them again. Alright. Now, if all goes well, which it probably won't, I should be able to hit play, and then this works out wonderfully for me. Alright. Do I want to continue? Let's say, yeah. Do I want to continue? 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 Yeah. Continue? No. All right, worked perfectly for me. One thing though, I probably want to do at the end of this structure here, each time I go here, I do probably want to put this on its own line here, as far as that goes for a new character. So if I come in here and I say like printf, open close parentheses, semicolon, what I can do is I can force a new line feed on this, and it'll make it a little prettier in the program. So let me just throw that in there. All right, say play. And do I want to continue? And I say, yeah. Do I want to continue? 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 Yeah. No. Whatever. Boom. Like so. And that is a do while loop. If I said no, it exits out right away. So I say yes. And there we go. Let's see a loop execution on this. So see what's going on with our program when we run this. So let's throw this into debug mode. And we're done with our whole statement there of our first loop here with our for loop, where it just blows right through it and does all the loop iterations. Let's have a look at this, what happens with this. So we're going to step over here like so. And so those two variables got set just now. So if I come in here, you'll see that count is 10 from before. Our response is, well, the end character, which is 110 inside the ASCII chart. And not finished is set to 0 as an integer. Okay. And then let's step over here and we get our printf here where we display our first message. So if we look at the output, it's now not there yet, but the moment we hit the next one here, we're going to get queried. Do we want to continue? I'm going to say y to that for yes. Okay. And then it's going to come down here, and if it matches y on either one of these, not finished is going to get set to, was it 1? Cool. So step over that, and bam. So it skips the rest of this, and it goes to our print line. It's going to automatically make it go one line here, and it's going to make it space it, like so. And then that's what we're going to encounter. So while not finished. So 1 means true, right? So it's set to 1. So it's going to continue to do the loop. Boom. And it pops back up here. And then it does the printf and scanf. And then for some reason it went through the whole loop without doing the scanf. Okay then, it's not supposed to do that. I was wondering why I was getting a double print. Now I see why. Yeah, I don't know why it's doing that. It shouldn't be doing that. Now it's asking me. Why? Now it's doing the scanf, whereas before it wouldn't. Um, I don't know what to say to this. This is weird. Yeah, okay. So if I say y to this again, it does it correctly now. Sets it to 1, like you would expect. Makes it space it while not finished. So back to the top here. Should be displaying it after the scanf here, and it should be prompting me. That's what it should be doing. But it's not. Oh my goodness. Well then, that's special. Not in a good way. And now it does it. Yeah, it's not supposed to do that. If I say no to end this headache, and the whole program finishes. I think I have to use double quotes on scanf if I remember right. Try single quotes, see what happens. I'm pretty sure that has to be double quotes for that. Oh, let's just run this. Segmentation fault. Yeah, so it doesn't like single quotes for that. Let's say it has to be double quotes. Well, due to some issue beyond my control, I guess, it's continuing to do stuff it's not supposed to. Let me try swapping this real quick from a good old do while to a while and see what happens here. Because it's kind of crazy. Let's see if this is a problem created by a do while. And that's all you have to do is switch it from a do while to a while. That's what I just did there. Right, I need to switch that too. Otherwise, it's false and the loop never executes. There we go. Now it's going to still do it in a while too. Weird. Okay, I'm not sure why it's doing that. It shouldn't be, but it is. Anyways, that's how a do while works. It does the first loop iteration before it comes down and does the test condition. And scanf should work every time, but apparently is not. Oh, we might have a problem where scanf's not getting what it expects here on the scanf. That's probably what the deal is here. I'll try this, but yeah, so that's what the deal is. It's wanting a different data type on it. Wow. Okay. So because of that, it's still correct. Okay. So that's probably where we're running into an issue. Alright, so I'm not used to working with WT chars, to be honest. Back when I was doing C back when, we never had those, so I don't know. But it still doesn't fix the problem. Right, so if I put an L here, it's going to be a type WT char. It doesn't really matter. Still not going to do it right, either way. So, it's whatever. So if I do a char here like this, then I have to not do a long C on this and just do a C, like so. And it makes it match the right data types on it, but for whatever reason, it's Xing out of it. Alright, in order to fix this, basically the problem we have is that it's taking in both the inner key and the character we type. So you type in, like, say, Y and then hit enter, and it takes in the Y key on the first pass. And the reason why it's skipping on the second pass is because it's passing it the enter key. And so we can't limit it down to just one key that way, the way it currently is anyways. So what we're going to do, we're going to say percent star C, and that'll make it ignore the enter key. And we only store the actual key, the first key they type, like for instance, like Y or N, and then the enter key is going to be ignored on the next pass around on it. This is an issue with scanf with chars apparently. So that's what we have to do in order to make this work. So when I say run, we get this do you want to continue thing. And then we say yes. And you'll notice it's just yes, 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 yes until we say no. And now it works properly. And then that's how we get rid of the problem of it continuously doing the enter key. If I don't want that space in there we were just getting, I just remove this printf down there at the bottom by putting a double slash on it to make it commented out. Run again. And now when I say yes, you notice it's right next to it. Yes, 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 yes. And then no if I want to end it. And it works. So that was the problem. We needed this special little %*C character here to ignore the enter key, because when it did the first loop iteration, it passed it Y. And then when it did the next loop iteration, it passed it the enter key. So it was not getting evaluated into Y in, it was going to the else. It was hitting else because of the enter key was getting pressed when we had to enter in response. There's no way to enter in just one character is like Y. You have to hit the enter key in order to enter it in. But the act of hitting the enter key to enter it in enters in two characters. So it's an issue. There's I can't think of another programming language where this is an issue in it. This is the only one I know of. And actually some other C programmers avoid scanf altogether because of this. So that's it's a problem with scanf basically. Anyways, that was the problem, and that's how you fix it. Alright, well, my name is Nate Nessler, and this is for Hyperactive Studios. Thank you very much.